Hey everyone, welcome to the Tom's Hardware Podcast for July 27th, 2021. As always, I'm Tom's Hardware Editor-in-Chief, Avram Pelch, and I am joined by Raspberry Pi expert Ash Puckett, Associate Editor Les Pounder, and to this week's special guest, 3D printing expert Andrew Sank. Andrew, it's so wonderful to have you on the show. As those who follow know, Andrew has been doing a lot of writing for Tom's Hardware, which is fantastic. It's made us really credible in the 3D printing space. And today we're going to talk about 3D printing and your Raspberry Pi. So what is your Pi experience like, Andrew?
So my Pi experience has primarily been building an octopus for 3D printing. A lot of what I do is really based in hardware. So Raspberry Pi has always been something that I'm always interested in from like an automation standpoint, but it's not something I've really integrated into my workflow. So today I thought what I would do for something a little bit different is I actually got, I asked Twitter last night what our favorite 3D Raspberry projects have been, and I got some really cool responses. So I thought those would be nice to share and kind of highlight some cool builds out in the community.
Awesome. So what have you seen?
So, all right, so I'm gonna go ahead and share my screen, which I've got a very low success rate of this sort of thing working on the first time. So we're gonna try that out. So we should be looking at a screen with some stuff on it.
Yep.
Okay, perfect. Cool. So yeah, so these are kind of a couple of examples of things that I think are representative of what you can do with the Raspberry Pi, and they're also fun ways to solve problems. This is a Raspberry Pi time-lapse camera. So if anybody's tried to make a time-lapse before with 3D printing, it can be kind of tricky. You have to set the interval correctly. You have to trigger a camera. There's a lot of retraction moves. It can be kind of complicated. So Denise Bertacci on Twitter at STL Denise 3D made this awesome Raspberry Pi cam. It was an Adafruit tutorial, and she actually added some custom graphics to it too. And if you go on her Twitter, you can see some of the time lapses she's made. They're really fantastic. And it's kind of a perfect example of where you would see a Raspberry Pi being used.
Great. By the way, I want to say to folks that while we don't have a beautiful case like that, we do have a tutorial on Tom's Hardware on how to do time-lapse Raspberry Pi camera work for those who are interested.
Yeah, absolutely. So there's actually, this is actually from Tom's. This was posted on Tom's Hardware. And so this is another cool example of kind of a creative project. This is by James Print and Play, so JC Print and Play on Twitter. And this is a full RGB computer with an LCD screen. And it's one of those things where you have to kind of do a double take. And I did a double take when I saw it. And you can see there's a can of Coke on top of it for scale. So this is sort of a miniaturized gaming computer. And James made this amazing video on YouTube on how he made this and kind of the design process. But a big part of it was because of the shortage of graphics cards and just a general chip shortage, it was really frustrating trying to build a gaming computer and integrate all of these lights and things like that and make it a fun process. So instead of just building like a 99% complete computer that had everything except the graphics card, he just miniaturized everything and made a Raspberry Pi version with all kinds of emulators and cool stuff built into it. And all the lights are programmable, and the files are available on Thingiverse. So if you want to make one of these, you can actually download this and print it out yourself.
But you would still have to get an acrylic panel, I assume.
Yeah, correct. So he actually cut a little acrylic panel out that he put on the side, and it's one of those, it's that little tiny detail that kind of brings this right over the edge. If you have a resin printer, you could probably, it's maybe 4 inches or something like that. If you tilted it, polished it up, you could also print it too. So there's all kinds of cool stuff you can do, combining 3D printing and Raspberry Pi. So let's do another one. This is an example of something that I saw in kind of a classroom setting. So Art Schultz from Waupaca Middle School created a donkey car. I'm not familiar with donkey cars. This is again, something I had to look up, and I just thought this was the coolest idea ever. It's a Raspberry Pi with a 3D printed chassis mounted on top of a pre-existing RC car. And so you're using Python to kind of drive it as a self-driving automated car, which you can kind of program the logic of. Again, it's just a really cool, kind of a fun example of what you can do with the Raspberry Pi and 3D printing.
Can you imagine how fun it is being in that middle school when that cart rolls out and they open up the doors and you get to pick which one you're going to play with? That picture just makes it look so exciting.
I know it looks like so much fun. It reminds me of like when you have a substitute teacher and they used to wheel out like a TV with a VCR attached to it, and that was like, yes, it's movie day. Like this is absolutely that same vibe of wheeling out all these little remote control cars, and it's like, great, this is awesome. We're about to have an RC car like race or Roomba exploration. Whose car can map the room the fastest?
And of course, arguing which color goes faster.
Probably the most important part of the process right there. This is another one. This is kind of a cool example of something that's a little bit more portable. This is actually a full arcade cabinet. And again, this is scaled down. So you're looking at a 5-inch vertical LCD attached to a gaming cabinet that was fully 3D printed. So it's using an Arduino Nano for the buttons, a Raspberry Pi for the emulation, and then the chassis itself was printed in a couple of pieces. Cool idea, cool execution, cool concept. Just a fantastic print in general.
Can you tell whether or not is that joystick 3D printed too?
Oh yeah, the whole thing is.
Yeah.
Oh wow.
Now, what about the Ms. Pac-Man logos? Are those stickers?
I'm not sure. I would assume those are stickers. You could program like a pause and print, but actually, I'm looking at it here from the side. That is definitely, yeah. You can kind of see there's an outline of a sticker line on the side. With enough time and dedication, you could print it, but probably easier to put a sticker on it.
Yeah, no doubt.
All right, and then I saved kind of the most complex one for last. This is an absolutely very unassuming looking but incredibly complex project by Max Sergey and Yafan, whose last name I couldn't find. Apologies. It's called the My House, the Smart Dollhouse, and the entire thing uses machine learning and gesture control to drive automation. So you can turn the fan on, you can turn the TV on, you can dim the lights and things like that, and that's all controlled through a PS Move controller. So you can actually control the house using gesture input. And it was one of those, again, just kind of a wacky, combines everything into a single project where you've just got all this technology creating something that, to me, like a real sign of success is from the outside, you're like, oh, okay, it looks easy. You just, make a swirling motion and then the fan turns on. But if you ask anybody to try and design that, it's going to take a minute. So the amount of effort and documentation that went into it, it's an awesome project. Highly recommend checking it out.
Wow, those are some fantastic uses of 3D printing for Raspberry Pi. The one thing I would say also is a really good use of 3D printing for Raspberry Pi is to make a case. So you saw that on some of those. The camera, for example, was in a specialized case. I was looking around this afternoon, and I was looking for, hey, what can I 3D print? So I found on Thingiverse. Would you say Thingiverse is the top place to find free designs to 3D print?
Yeah, it's definitely the largest repository, and it's been around since MakerBot started making printers, so 2011 or something like that. So if you're looking for something, there's a really good chance you'll find it there.
Yeah, so I found this design on Thingiverse. Now this is for Raspberry Pi Pico, and it was actually posted by Adafruit of all places, because they do some 3D printing stuff. And what this is supposed to do, now, word of caution, one thing I've learned in 3D printing for the last few weeks is that things don't always come out the way that you hope or expect. But you can snap your Pico into this, and that's great. And the back of it should attach to a Lego, anything with Lego studs on it. But when I just tested it, it didn't. So you have to keep an eye out for, hey, things aren't always going to work. Obviously, if you're a designer and you can work with the CAD software, you can probably fix things like this. It may also depend on, maybe it worked for somebody else with a different 3D printer than yours, and you expect that it'll work the same on yours, but maybe not exactly. So, you got to give things a shot. I've had a lot of failed or prints that succeeded but didn't do what we wanted, or failed. I tried printing it again with the separate bottom and top, and maybe the studs on this will work better. I'll have to try this. I have to try this after, but obviously designing or finding an existing Raspberry Pi case is a great use. Is a great use of it. I've also seen a number of robot setups. So besides the cars that you showed, I've seen some setups for robot arms that you can print all the pieces out. Now, word of caution, a lot of these things you can't print every piece. You can print the plastic, but you'll still need to buy the screws, and you'll still need to buy the motors. Maybe that's obvious, but there's still a lot of different things that you have to attach, that you can't just take a spool and have a working robot. Ash, what do you have there? It looks like you have a 3D printed robot.
Yeah, with a Pi inside. We even put a Raspberry Pi logo on it. We've demoed this in a previous podcast episode, and I don't have it powered up right now, but it's a little spider bot. The shell is 3D printed, and there's a Raspberry Pi inside, and we have a little slot there to get to your SD card real easy. But I just wanted to point out how you usually, like Abram was saying, have to add on extra components, servos to make those legs move and things like that.
Now, did you design, just remind us, did you design that one yourself, or did you find it as an existing design?
A little bit of both. Found an existing design and then just kind of modified it, like to change the body to fit all the stuff we wanted inside and the battery pack and everything like that. So it started, that's as a lot of things do on Thingiverse, starts with somebody else's project and then branches off.
So what do you use, Ash, when you're trying to modify a design? What software do you like to use?
Blender. I always use Blender because it's free and it's open source, and I know a lot of other people will recommend things like I want to say Fusion 360, which is also good, but when it comes to licensing, I like the ability to sell something if I wanted to, or use it in a business purpose if I want. So if you can take the time to learn Blender, it is really beneficial.
What do you use, Andrew? What's your 3D software of choice?
So for hard surface modeling, I use SolidWorks primarily. It's a really powerful program, but it's more kind of enterprise level. I'm totally with Ash. I'm actually a big Blender fan, and I've used Blender for years, but it's hard. It's so hard to recommend because the learning curve is so steep in the beginning. It's an incredibly it's like a 747. It's incredibly powerful, but without training, if you get dropped in the cockpit, it's sort of like, God, there's a lot of buttons here. And so sometimes things that we take for granted, like the ability to work in set units in Blender uses BU or Blender units. And so if you get dropped into that, you're like, well, what's 1 BU to 10 millimeters or something? And there's a lot in the beginning, things that you would sort of expect to work easily, but maybe they don't. I recommend Tinkercad. Is a really easy program for getting started for making things like enclosures. But it lacks some of that ability to really get in and make detailed changes to models.
Yeah, I mean, I've tried Tinkercad a bit, which is a web-based software that anyone can use, and I had some issues with it because it doesn't feel very precise. You got to do a lot of dragging around with your mouse to get things where you want them, so you can't just easily necessarily type in, hey, I just want this in this spot. So I had a circumstance. This actually has kind of worked out. Let's see if this one works. Where I had a robot here. This is actually a chassis that my son and I bought. This is an STS Pi from Pimoroni. And one of the features of it is that it came with an acrylic piece that you put here that holds a camera. Well, wouldn't you know it, one of the legs, my son drove it into a wall, and one of the legs on the acrylic piece cracked. I thought this is a perfect situation where you would really be able to replace the camera mount with a 3D printed part, and that's what you really want, right? So I went online and I found that somebody had created not exactly what I was looking for, but close. They had created a mount for this to mount an ultrasonic sensor, not mount the camera, but mount something else with feet that fit into here. So I went and I said, hey, how hard would it be to just erase the 2 holes for the ultrasonic sensor and put a hole for the camera, which I did. But I couldn't get the little holes in Tinkercad to actually go away. They're sort of still there, and I have no idea how to make them actually go away. Like, I guess it doesn't matter. because they're covered, but it's just weird. Like I had to draw, instead of just erasing the holes, I had to draw little cylinders to fill in the holes, and they couldn't fill them in 100%. So you have this little indentation, which is weird. Then talking about having problems with things not exactly working, the first draft of this that I printed, it didn't snap. And actually, I think this is the first draft one. It didn't snap, right? Why didn't it snap? It was like half a millimeter too long. Now, whoever made it, I don't know how it worked for them, but anyway, so what did I do? I think this is still the one that doesn't fit. I had two of them. No, this is the one that fits. I had one that was two, so now you see this fits. But I had one before that was a half a millimeter and a half too long, and I shrank it, but shrinking it in Tinkercad was too annoying and difficult to just shave like half a millimeter off. You can't just say shrink me by like a millimeter or half a millimeter. So I did that in the FlashForge printing software instead. I cut, this was purely just trial and error, 1.5 millimeters off of the width, and magically it fit. So, those are the type of problems that I think I've been running into with 3D printing, because you get something, but it doesn't quite do what you expect. Now you've got to try and make a small change, and something that seemingly would be easy, you would think would be easy enough to do, shrink something by a little amount, fill in a hole, seems to be more effort than I think it should be. But I mean, that's, look, if everything was easy, then life would be no fun. So we have to have, we have to rise to the challenge.
Slicers like clean files. That is definitely true. Any artifact is going to show up when you try to print. I have a question for you, Andrew. You mentioned SolidWorks. I've been looking at an open source alternative because if I want to make something mechanical that moves, I want the ability to move the part on the computer to make sure it moves together. Have you any experience with OpenSCAD?
Yeah, I do. OpenSCAD is another one of those like Blender. It's really powerful. I've used it. Haven't used it a ton. I mostly use it for like academic purposes, just kind of learning about it. But it is OpenSCAD, for anybody who's unaware, it's more of a command line interface for creating 3D models. So as opposed to drawing a cube or sketching a cube, you would actually define a square with a set extrusion. So you would set your XY plane, and you'd say, okay, 10 units X, 10 units Y, and extrude 10 units Z, and now you've got a 10 by 10 by 10 square cube. Sorry. So it's for people who, if you're used to programming, if you're used to Python, if you're used to, if you have a lot of experience, it's a very intuitive language. For anybody who works, like I'm a very visual person, I need to see things sort of sketched out, and I need to draw it, and then look at a couple different, isometric views before it clicks in my head. So OpenSCAD is something that I haven't really used. Something, Ash, you might be interested in is FreeCAD. It's similar to SolidWorks in that it is a parametric program. So parametric means you've assigned parameters. So parameters meaning length, height, whatever. But you can make changes on the fly. So like you can print a water bottle, and then, or you can design it and say, well, you know what, I like this, but I wish it was 10 millimeters taller. And so all you have to do is change 50 to 60, and it'll automatically jump, while keeping everything else, like where the handle location is, relative. Which is, again, it sounds very trivial, but it turns into a real headache when you're designing things in Blender, and like you make a change and everything, you just watch it crumble.
And that was FreeCAD, you said?
FreeCAD, yeah, and here's a tie-in for the podcast. Someone actually got it running on a Raspberry Pi, so you could build a computer that just runs FreeCAD.
That's awesome.
There you go. How long do you think it will take you to draw something when it's running on a Raspberry Pi?
I think they said 7 frames per second was what they were getting. So like, I certainly feasible. Like it's definitely not, you're not going to shatter any records with it, but it works. And a lot of what you're experiencing, the problems with, especially with that little Pi interface, when you think about a 3D model, we think of 3D models as STL files. That's what's called a mesh file. For anybody who's ever done any 3D modeling, when you make a cube, what you've actually made are 6 surfaces, and those surfaces don't really have geometry. They're just infinitely thin surfaces. An STL file is like you threw a net around that cube and pulled it tight. And what you're looking at are all of the nodes that connect it. So a slicer doesn't see a cube, it sees a bunch of triangles. So each face of the cube, like each square, is 2 triangles cut down the middle. So you have 6 points and then 2 triangles, 3 points each. That is really hard if you say, I want to erase a surface. There's no surface, it's just triangles. So slicer programs in Tinkercad can get really kind of flustered, like, well, what are you trying to do? Which is why programs like Blender and SolidWorks we call them addressable surfaces. So for instance, those 2 holes that you wanted to delete, if that was a solid model, you can click that hole and say delete and erase that feature. But if it's a triangle, it's actually, if you look kind of zoom in, you'll see all the little facets because it's a bunch of little triangles that make up that circle.
Yeah, it was a challenge, and also just, I thought I had drawn a cylinder that would just completely fill it, but still there's a little border around it, which is, I guess it's no harm, but it's obviously not, not what you would want. Now, I've had a lot of great experiences printing other people's great models. This is not a 100% Raspberry Pi thing, but we've made things like this, which is a little Mario trophy star. This guy here, who's needs to be painted better, but is a Luigi that holds your Nintendo Switch. This little mushroom here. My son is really into printing Mario-related things. We had printed, I don't have them here because I gave them away, but we went to visit some friends last weekend and we printed a whole bunch of stuff to give them. Glasses holders that you stick your glasses on, and cartridge holders and things like that. So if you want to make cute models and things that hold something up, that's pretty easy. But when you get to doing things that need to be exact and precise, then it's another level. Like, I'm still waiting to see if this thing works that I printed last night. Can anybody guess what this is?
It looks like it's supposed to be a coupler. It's got like a relief cut in the side. Is that right?
Yes, it is not a toilet paper roll. This is for the printer because this printer that I'm using here is the FlashForge Adventurer 3, which has been fantastic. But the one big flaw in it is that it can only hold a half kilogram spool. When folks who have been doing 3D printing for a while know that almost everything is a 1 kilogram spool when you're using an FDM printer. So this is a thing that you stick in the side and it juts out. So hopefully you can put a larger spool on it. However, on Thingiverse, some people said that this cracked in half when they tried to use a kilogram spool, and some people said it worked fine.
How much infill did you use?
100%.
So before you use that, I would make sure don't put anything valuable underneath it. So the way it's printed, it's because it's stacked vertically. The prints fail at the thinnest point, just like anything else. Like it'll crack at the thinnest spot. So when you print it upright, what you're basically doing is balancing quarters on top of each other. So there is a failure point between each layer. So where your pointer finger is right now, just a touch up from there, is going to be where that flange meets the rest of the shaft, and it shrinks. So if you put weight on it, that's where it's going to snap. So it's not intuitive because you think of a cylinder and you're like, well, it can print upright. The best way to print that would be to make an octagon shape instead. So it's a set series of planes and then print it on its side. So the stress is going lengthwise because you're going to be experiencing force. The filament spool is going to push down on it. So you want it to bend and be pliable. Like I actually I made this. I'm working on an article right now for Tom's on how to make multicolor parts. And so this was printed laying down flat. So I can bend this and you can kind of see it's deflecting. But if this had been printed upright, if you go, it's going to snap because that's just where the thinnest spot is.
Yeah, this is how they had it on Thingiverse. I did not modify it in any way except to make it 100% infill so that it would supposedly be stronger.
You can put a broom handle inside it and it'll be good to go.
I guess, except you got to stick this into the hole. Yeah, we'll figure it out. I'm also going to use, I think if I use this in combination with those things that you gave me that actually have like little wheels on it, little ball bearings on them to hold the spool, the bottom of the spool, maybe that will help. I don't know. Well,
You don't even need the spool holder if you use those. So what we're talking about are filament skates, and it's basically just 2 ball bearings that are
yeah,
held captive, and you put the filament spool between them. So the ball bearings both rotate, and the filament spool can move around. So you can put a filament spool on a desk, and then this thing will move. That's how I used the Adventurer 3 before I sent it up to you.
yeah. So anyway, we'll see. We'll see what happens. But it's neat to see all the different things that you can do with the 3D printer to really, you combine that with your Raspberry Pi, with your circuit, or with your microcontroller like a Pico, and then you can do a lot of other things with it. But you've got to make sure you have the right material, the right design, and be willing to fail. So speaking of things that are interesting to try, Les, you have a new Raspberry Pi tablet.
I do indeed, yes. It's something you can see. It's called Reterminal. Now, excuse me, the overhead camera is not working tonight. It's going to have to do this the old-fashioned way, where I put it up to the screen. So this is a 5-inch tablet with a Raspberry Pi. It is, isn't it? A Raspberry Pi Compute Module 4. Let's try and get that in shot. There we go. Also, I'm touching the heatsink, and it's quite hot because it's been on for 4 hours. Raspberry Pi Compute Module 4, 4 gig model with 32 gig eMMC. So it's got storage. It's got Wi-Fi as well. Full touchscreen, 1280 by 720. And it's made for like industrial embedded Linux projects. So I was going to show you around a little bit. Full GPIO on the side. It is compatible. You can put a hat on there. It'd be a bit of a tight squeeze, but you can do it. Best off with a breakout board of some sort. Let's take you around to this side now. And we will see there's a USB-C interface there. That's actually powering it. This tablet hasn't got a battery inside it. It's just like, it's not really a tablet to go out and walk around with and play music. It's there for something to be embedded on your desk to do something. We've got micro HDMI, gigabit Ethernet, and 2 USB 2.0 ports. We've also got an expansion port on the back here, which is hidden, to connect into other devices. There are accessories available from Seed to connect to this. And let's just put that on nice and neat. You'll have noticed when I was spinning it around, there's these little screw points. There we go. And there's 2 on here, and there's 1 on the bottom here. So the 2 on each side, the smaller ones, are for attaching Seed's own attachments, so extra fittings and sensors, that sort of thing. And the one on the bottom is a standard camera mount that's put onto a tripod or onto one of the little stands you can buy.
Is there a camera?
There's no camera. No, you can plug the camera in. I was going to get to that. There you go. There's a camera slot there. So you can run the camera out. And there is an attachment to fit it on nice and neat. So, yeah. It's running Raspberry Pi OS, but it's got some special software you can't see, unfortunately, because it's a white background. But it's running some CPU stats at the moment in a very nice little test environment. Built into it, see if you can pick this up. No, it's just going to keep flaring out. Built into it, there are some sensors. So we've got an inertial measurement unit, IMU, which can measure shock forces, acceleration forces, that sort of thing. And right now, it's measuring me shaking this to see what forces are exerted. I can also see a light sensor. And if I run my finger, it's about here, the sensor. I can see it going dark. If I move it away, it goes light again. I can test the buttons, check they're working. And I've got a little touch interface here to show that the touch panel's working. But this is really made for like an embedded project. So say you wanted to build a controller of some sort for a project. You could build it with this and control it remotely. So I was thinking this to make a good one, something like, what's it called now? The DNS spam filter, Pi-hole, that's it. You could put Pi-hole on this and you could see all the stats of what was going on, see how many adverts are being blocked, that sort of thing. Or you could use it as some sort of file server connected up so you can see current status of your server. It looks really cool. Now, the price of this is $195. That does include the cost of a Compute Module 4. And you can take it apart, and if you want to put a more expensive, more powerful CM4 model or a future CM5 model, perhaps in the future, if it has the same interface, that is possible. And I'm just currently putting this through its paces for review on Tom's Hardware.
So you said it doesn't run Raspberry Pi OS? Like, what's the...
It does.
So it's a special interface on top of Raspberry Pi OS?
It's Raspberry Pi OS default, and there's an app on there made by Seed which shows off how to use the board.
So what, I mean, it seems like to me like an odd form factor to have if you're not going to have a battery. What are some of the attachments? Is there a battery attachment?
I haven't seen a battery attachment. No, I'm on Seed's website now, and the attachments we've got are mainly modular design. So they're made for putting in connections of RS485 connections, so industrial connections. So you have this device embedded somewhere, and you have these connections on to monitor certain things, so network perhaps, or some sort of industrial application. There aren't a lot of accessories at the moment. There's like one or two that I can see on the website. Muted, Abram.
What do you think, Ash and Andrew? Would you use this for something?
I could see myself using it for something dedicated. Like Les pointed out, it would make a good screen for something like, I already forgot the name of it too. Pi-hole.
Pi-hole?
Yeah, something like that. Or maybe you wanted to just keep an eye on your computer stats, see if something is running hot while you're in the middle of the game and don't want to have like a second monitor set up. You can just have a little
Box of Pi? Have Box of Pi running on it so you can monitor your 3D printer. That's on topic. There we go.
Yeah, there you go.
Yeah, immediate... Oh, sorry, go ahead.
No, you're going to say?
The immediate thing that jumps out at me is kind of, we were talking about FreeCAD running on a Raspberry Pi a minute ago. And so here we've got a Raspberry Pi with a screen and 2 USB ports integrated. So what jumps out at me is having a 3D printer with an adapter on one of the aluminum rails with this thing mounted on top. And now you've basically got a portable printer CAD station. So all you hook up a battery to it, and now you've pretty much got a machine that can design and print things that you can sort of take anywhere, which is one of those way science fiction ideas until someone takes two things that exist and glues them together.
Yeah, but even then, if you want to take it anywhere, you kind of want battery. Now, I see what they've sort of tried to solve for, which is, Ash, somewhere you have the other recent Raspberry Pi tablet that we reviewed, don't you?
The RasPad.
The RasPad, right? And that thing is really thick.
Right?
Yeah, it is. It is super thick, right?
But it's useful sort of with this because you can sit it upright like this. So if you sit it on a desk and like it's good for displaying stuff. I've used it like that a lot. Like I have recipes and stuff on here. I have a little recipe app and I just sit it up in the kitchen and just swipe through whatever I'm playing with.
So that's, that's a lot bigger and heavier. So, and that has a fan that makes a fair amount of noise, right? Does this have a fan?
Can you hear it? I'm holding it by the microphone. It's that
loud.
Yeah.
How about the reterminal? Does that have a fan?
No, it's got a heatsink on the back of it, which is what I was holding, and it's because it's been on for about 4 hours, doing quite a lot of work. It's about 60 degrees C right now. In fact, I can tell you on the sensor now. Oh, it's gone down to 50, which is lovely. So yeah, it's all passively cooled on here. But Ash, I know it's on the RasPad. Lee PSP Video did a video recently where he replaced the fan on the RasPad with a better fan, basically. Something like Pimoroni's fan, the fan chip. And apparently it's silent now, and there's no interruption to the usability of it.
That sounds necessary.
Yeah, so that's a plan. But I mean, I like the design of the reterminal better. It looks a lot nicer and thinner and more professional than the RasPad. But you definitely would have to say, hey, I'm putting this somewhere where I don't need a battery. And I mean, also, I think it's neat that it has buttons on it, right? How many buttons does it have?
We have 3 standard buttons plus 1 enter button. And there is another one on the top which apparently controls power, but I'm thinking that could be connected to a GPIO pin to do something special.
I do like that the GPIO is exposed on it. That is a big selling point, I think.
That's good. I think for $195 they could have given you USB 3. That's
true. When you consider Seeds did this board as well, which we reviewed last week.
Yeah,
that's got USB 3 on it.
Right.
That would have been a really nice addition, but I mean, USB 3 is not default on the Compute Module 4, it's USB 2.
true, but for that kind of money, they should at least give you the three. Obviously, they could have. So I mean, but it is it does look like a really nice design for what it is. It gives you buttons, which the RasPad does not. It gives you really nice outputs. I would also love to see an easy way to mount the camera on it, because I mean, there's your, you could use it to monitor your prints. I would use it probably, and I could get away with this without a battery. It's like I still want to set up some kind of really nice, sleek telepresence station or something. I might, where folks from work can like dial in and see me, or see that I'm not here and complain. Anyway, speaking of things folks are working on, Ash, you had one thing you wanted to show, a way that people could actually test the Raspberry Pi without actually having all the electronics.
Yes, it's really cool. And I didn't notice this at first, but I apparently covered this project a year ago. So let me switch screens real quick and show you guys. Here's the post from July 30th, 2020. This is whenever we first touched on this. This was a project created by a teacher named Jean KS. He created a GPIO simulator to help students working remotely. And today I'm sharing a new update with you guys about the project. So earlier this week, Jean released the TK GPIO Python library for users to check out for themselves. Before, it was just something he was sharing. Now we can actually get our hands on it and play with it. So it's been released to both GitHub and PyPy. And this morning, Les and I spent some time trying to get it set up. And unfortunately, I ran into an issue on my Raspberry Pi with my NumPy version, and I don't have a live demo running for us. However, I would love to take a moment to explain how it works and go over a sample demo that was provided by Jean that shows just how easy it is to use the TK GPIO library, because it is really neat to check out. So the way it works, first you'll have to install the TK GPIO library. The official documentation recommends just pip install TK GPIO. Assuming that all goes smoothly, you can now use the library to program a custom circuit. And it has all sorts of components that you can play with, and there are plans in the works to add more. There's a list on the GitHub page that mentions LEDs, buzzers, DC motors, push buttons, switches, light sensors, motion sensors, you name it, and you can toggle things like how fast the servo is supposed to be spinning or how much light the light sensor is supposed to be receiving to get real-time output from your projects. And with that being said, I want to walk through an example code, a demo project that was created by John. So let me pull it up here so you can see exactly how it's supposed to work. So the first thing that it does is import TK circuit from the TK GPIO library. And this allows us to create the GUI window that we want for our custom circuit. We can define its width, its height, which components we want to use, where they're placed on the window using X and Y coordinates. We can choose what they're called and exactly which pin we want them to be assigned to. And after the circuit GUI is defined at the top, it's just a matter of programming as you normally would on the Raspberry Pi. The GPIO pins that you use in your code will correspond with the ones that you defined in the circuit for TK GPIO at the top. And once you finish programming, you can save the file as a regular .py Python file and then run it. And the end result should be a custom GUI window that opens up with your components appropriately placed. They should be labeled with the name that you gave them, and then you can interact with them. Click to toggle the LED or whatever you were doing. So if you want to take a closer look at this project and try it for yourself, hopefully you have better luck than I did. I called user error on that. Visit the project page at github.com/Wally Salami. That's WALLYSALAMI/TKGPIO. And I want to know, what do you guys think? Do you see yourselves using a tool like this to test out ideas so you don't have to dig out the old breadboard?
Yeah, I could definitely see that.
Yeah, definitely. I've used something similar by Tinkercad, in fact. We've been talking earlier. They have one for the Arduino where you can drag and drop circuits together and use a virtual Arduino and simulate projects. So if you haven't got access to the hardware, it's great to use a simulator like this to play around and understand, the theory and the practicality of it all.
Yeah, that makes a lot of sense.
That
Wow.
definitely seems like a quick way to like cut off a lot of frustration in like the hardware prototyping phase by going through some of the early iterations and running into those bugs right off the bat. I've got my Raspberry Pi project for 2021. This is something I'd like to build by the end of the year. I'm doing a lot of photogrammetry right now, which involves putting something on a turntable, taking a picture, moving it just a little bit, taking another picture, and then once you've completed a full circuit, lifting the camera up like 30 degrees. And the other day I thought, man, wouldn't it be great if I had something that could rotate the turntable, take a picture, like trigger the camera, rotate, trigger, rotate, and then after it completes a full revolution, have a servo that then lifts the camera. So the camera will be mounted on kind of like a C-shaped arm. And it's one of those things where I had the idea, and now it's just a matter of, okay, all right, fine, I'll write down sketch. So the hardware prototyping is the fun part, but that initial sort of going through the Raspberry Pi, what does that look like? What am I triggering? How am I sending these commands, and where am I sending them to? Being able to do that in software before you get to the hardware phase is just a massive time saver.
Yeah, no question about it.
Or remote students.
Yeah, no question about it. So I want to thank Andrew for joining us this week, and all of you who watch and listen. You can catch us anytime on YouTube or Facebook, and we're live here Tuesdays at 2:30 p.m. Eastern, 7:30 p.m. UK time, and we will see you next week. Bye, everyone.